Hello, in this short video, let's look at the types of MOSFETs that are present. So, if you remember from the MOSFET working model, inversion charge is the reason why we have conduction in MOSFETs. So, the inversion charge can be made up of electrons or holes, and hence you can engineer two kinds of MOSFETs, namely the P MOSFET or the N MOSFET, depending on whether the inversion charge is a hole or an electron. So now let's place them next to each other and compare the two. So the MOS structures are essentially as shown here. So in this structure you have a p-type substrate and you have N plus source and drain, whereas on the PMOS you have an N-type substrate with P plus source and drain. Okay? In most cases the gate work function between the NMOS and PMOS are different. So therefore I've indicated them as two separate colors which are specific to both the gate of the P and the N. So ideally at 0, when VGS is 0 in both cases, you have some sort of a depletion region between the two, right? And now what happens is, let's assume that our source is at 0. Now to invert the channel in the N MOSFET, you need to apply a gate voltage that is positive. So when VGS is positive, this depletion region expands and eventually an inversion charge is created, which is an electronic charge. On the other hand, in the PMOS, you apply a negative voltage and you create this wide depletion region, and eventually you create an inversion channel which is made up of holes or positively charged particles. And so these holes are present in the PMOS, the electron is present in the NMOS. Now remember, the source in both these structures is 0. And now when you want the electron and the hole to move, what do you want to do? You want to essentially apply a negative voltage at the drain in the PMOS for the hole to move from the source to drain. So remember, carriers always move from source to drain. So in the case of the PMOS, the drain is at a lower voltage than the source, and hence the hole moves from source to drain. The NMOS, we apply a voltage which is greater than 0 at the drain, and therefore the electron moves from source to drain. Which means that the drain current in the PMOS actually flows from source to drain, because the hole moves from source to drain, and since the hole is a positively charged particle, the current is directed in the direction from source to drain. In the NMOS, however, the current moves from drain to source. So remember, in the NMOS, VDA is positive, VGS is greater than 0, or the VT of the structure is positive, and that's when an IDS flows. In a PMOSFET, VGS is negative, the VT of this transistor is negative, and for current to flow, current flows when the drain voltage is less than the gate voltage. And also remember that the direction of current is different in the two. In the NMOS, current flows from drain to source. In the PMOS, the current moves from source to drain. So given that, the symbols of the NMOS and PMOS are as below. Typically we use these symbols where the arrow indicates whether it's an NMOS or a PMOS. So in an NMOS, remember, all VGS and VDS are positive, VT is positive, and current direction indicated by this arrow shows that the current flows from drain to source, where the resistance of the channel is controlled by the gate. In the PMOS, on the other hand, VT is less than 0, VGS is less than 0, VDS is less than 0, and the current flows from source to drain, again with the channel controlled by the gate. Generally, if you compare PMOS and NMOS, and this is specifically related to silicon and silicon germanium, which are normally used in compute devices today, electron mobility tends to be higher than hole mobility. So in general, for similar voltages and threshold voltages, the current in the NMOS tends to be higher than the current in the PMOS. And second thing which normally we see, especially in later technologies, is that the threshold voltage of the NMOS generally tends to be slightly higher than the threshold voltage of the PMOS. So again, transistors are broadly classified into P and N type based on their carrier type. And we'd use both of these kind of transistors when we're going to build CMOS circuitry, and both of them have specific functions in CMOS circuits, and they generally tend to complement each other.